A very good morning to everyone. Myself Satish Kumar, handling technical support engineer in AGS. So today, actually, we are going to see what are all the various SolidWorks solutions that will be helpful for the industrial equipment design. What is the agenda today is we can able to see what is the latest trends that is available in the industrial equipment industry and what are the common challenges facing by these industries to their day-to-day life, and also what is the common industry process they are following inside their industry for each projects, and how the SolidWorks functionalities will be really helpful for to make them their designs and their and to improve their productivity, and also finally how to validate their design in their design stage. So at the end we will see some of the benefits that is given by the SolidWorks. Okay, so what are all the industrial trends today? If we are getting into the industrial equipment design, there are a lot of machineries is updated in our day-to-day life, right? So every machinery is having the unique capabilities in the mechanism side and also as well as the design side. So if we need to do the custom machines for to improve our productivity in the market and also to come across the global competition, right? So obviously we need to make some adjustment, and also we need to make some collaboration with our design and manufacturing into a quick way. So for that we need to have a better designing area, and also we need to do the entire designs in a shortest cycle time. So then only we can able to be bigger in the market, and also we can compete with our global competitors. So the common challenges facing by these vertical industry is their machines are more electronic, so they need to integrate their mechanical with the electrical, and also they need to check the assembly fitness problem during the design stage. So if they doesn't do that, they are struggling in the shop floor area. After making the machine, then only they come to know there is some problem in between the components assembly, there is some fitness problem, there is some mismatch in the assembly manufacturing, so they need to concentrate on those kind of areas. So and also they need to increase their reliability to make bigger in the market, and also they need to do lot of product innovation in their day-to-day life. So the industry process, generally if we take an industry and if we see the process, first they'll have some R&D team, they'll do the analysis for the new product development, and also after that they'll make a design nowadays, and also after that for the design which is a suitable material for my design, which is the suitable material to withstand the strength of the machine, and also after that if everything is okay, then they will go for manufacturing and assembly test by making the prototype. Then at the end they'll do the documentations for the proper machinery instructions, and again if they will get into the cycle, this cycle process. So the SolidWorks functionality for these industrial equipment is we can able to easily make our part level and assembly level modeling, and also as well as the manufacturing drawing. So obviously in normal days we are facing a lot of challenges while making the drawing for the manufacturing, right? So here we can able to eliminate those kind of design errors, and also we can able to overcome those kind of manufacturing drawing functionality problems. And also here we can also able to check the manufacturing feasibility of the product during the design stage, and the assembly fitness problem, yes, we can able to identify while we are making the design itself. And also in this kind of industrial equipments we are dealing with a lot of inline components, right? So those inline components we can able to access through our hardware library that is already available, and at the end obviously we are validating our design to ensure whether my product will long life or not, how it will break or where it will break. These kind of validations we can able to done it here. So the part and assembly creation, if you see inside the SolidWorks, the user interface is very helpful for you and also very easy for you. So this is a Windows based application, so you can able to easily learn the software within few days. And also the software will suggest you if you've done any mistakes. The software will help you to resolve the issues and overcome and make your design properly. So in the display you can able to see this is one of the capping machine. So here there is some incomplete in the entire model, so I'm going to complete the model. So here actually what I need is I need a motor. So I don't want to create, I don't want to spend my time to create those kind of inline components. In the right side you can able to see there is a design library. So the components, though you are frequently used, you can able to directly switch over from the library and use it in your assembly. You don't want to spend your time for to create those kind of things. So and also I need a motor for this gearbox. I can able to get it from my design library and I choose here. So after finish this, what I need is, oh, sorry. Okay. So after finish this, what I want to do is I need to bolt the motor and the gearbox. So these also I can't able to, I don't want to spend my time to create those kind of things. I can able to get the software. I can able to tell the software to fill all these kind of bolts and smart fasteners from my toolbox library. Okay. So once if you done the model, you can able to see in the screen. You can easily complete your model sets without spending your time for creating these kind of inline components, right? So once if you make all these kind of things, you can able to make the part level drawing and also the assembly level drawing without any design errors. And also in the design stage itself you can able to check the manufacturing feasibility of the product also. So once if you done this, you can able to make the drawing from for this entire assembly and also as well as the part level. So let me switch over into the presentation. So with this, you can able to make your part and assembly creation in a very shortest time. So obviously nowadays what is happening, if you are making some drawing, if you are making some part level and assembly level documentations, there is always a distraction between the design team and the manufacturing team. This dimension is missing. This is not properly mentioned for manufacturing. So that's those kind of problems we can able to rectify during the design stage. You can able to make your designs as like the standard formats like ISO and C, and also you can able to check the manufacturing features. I dimension the manufacturing features or not, those kind of informations you can able to rectify inside the SolidWorks. And also you can able to communicate your drawing with your manufacturing team or your suppliers in a clear way. So once if I done this modeling, I can able to get the manufacturing drawing with the updated bill of materials. While once I make the modification in my modeling, in my assembly, that will be automatically reflected in my bill of material. So once if I done this, I can able to get the updated bill of material for my entire assembly. So if you want to see my entire assembly in exploded view, that also I can able to done it. So this will be giving a better understanding to the shop floor people to find out how my assembly is assembling. And also they can able to make the ballooning for their entire assembly to identify which component is available in where. They can able to get a better understanding about the product. So with this they'll get some clear cut idea about their assembly and also as well as their manufacturing drawing, right? Yeah, fine. So with this, actually, they can also be able to check the manufacturing feasibility of the product during the design stage. So once if you are making the part level design and if we give it to the shop floor people, then after it reaches the shop floor people, they'll say this tool is not available in our shop floor. This machinery, by using this machinery, we can't able to do this kind of operations. So these kind of things we can able to identify during the design stage, and we can rectify the impossible operations by using our shop floor while we are making the design. So it is actually the upfront validation tool for our manufacturability, and also we can able to identify the features which are all not able to manufacture in our shop floor. So the next thing in the industrial equipment design is the assembly fitness problem. So if you are making an assembly, and also if we want to check what is the maximum tolerance and minimum tolerance is affecting the other parts, how I need to assemble the entire assembly. So those kind of things we are struggling a lot. So once if we done the assembly, and if we put the component in the fixture area, that will not fixed in that area. So why it is? Because due to mismatch of the assembly components manufacturing, and also the improper tolerance we are given. So these kind of things we can able to eliminate during the design stage. We can able to reduce the prototype testing. Instead of doing that in the design stage itself, we can able to identify the maximum important tolerance during the design stage, and also we can able to find out the minimum nominal value and also the maximum nominal value, which tolerance value is giving more preference for this set of assembly. We can able to identify those kind of things. So, and one more thing, in the industrial equipment manufacturing, we are dealing with a lot of inline components like nuts, bolts, bearings, jigs, fixtures, keys, lot of inline components. So inside the Solidworks, we are having a hardware library of around 18 different country standards with lakhs and lakhs of components that is already predefined available. So we can able to directly get the library and use it in our assembly without creating those kind of components again. So let me switch over into my assembly. So here I'll open a model. So in the screen, actually, you're seeing one of the assembly that is having a different hole sets. So in the screen, you can able to see counter sink, counter bore, and normal bore. There are a lot of different holes is available. So once if I want to fill all these holes with the fasteners, means what I do normally, I'll create the standard fasteners first, and I'll save it to the folder. And again, I want to assemble in each holes, right? So instead of doing that, if I'm having the hardware library, I'll tell the software to fix up this kind of fasteners. The software will get from the toolbox appropriate fasteners, and it will fill automatically for all the holes. So even though not only for fasteners, if I am using any bearings, nuts, bolts, or jigs, bushes, keys, anything, I can able to get it from my toolbox. So you can see in the display, the holes will be automatically filled by the appropriate standard fasteners from my hardware library. So in the right side, you can able to see there are a lot of inline components that is already available in a predefined standards, different varieties, and also as well as the different sizes. So using this library, you can able to improve your productivity by reducing to spending on the time for to creating this kind of inline components. So obviously, once I finish the design, I'll get into the analysis area. How long will my product long? And also, I need to ensure the strength of the product. My product will withstand this much amount of load or this much amount of weight. I need to ensure without making the prototype. Is there any option to find out these kind of things? Means yes, that is possible by using the SolidWorks simulations. It is actually the upfront validation tool for your entire machinery during the design stage. So it doesn't need any separate analyst. The designer can able to do it if he knows the functionality of the machinery. So here actually I'm having one of the crank. So I need to check the crank will withstand the load I gave or not. So if you are considering the simulation, you don't need to be an expert in the finite element analysis. You can able to deal with this simulation because this is a very user friendly software for you. So you need to do in a simple steps. So if you are getting into the simulation, the software will suggest you the step-by-step instruction for you to do how the analysis will happen. So if you are getting into the simulation, the software will tell you what are all the scenarios I need to do to analyze my entire model. So in this analysis, what I'm going to do is the simulation advisor. This was I said. What are all the steps I need to do the analysis for this entire model? The software will guide me. First, I need to study the model and I need to apply the materials, everything, and I need to give the interactions between each component. And at the end, I'll run the results. So in the display, you can able to see. First, I need to apply the material. Solidworks is already having around lakhs of standard materials with all the material properties like yield strength, elastic modulus, everything. So, and after that, I need to provide the connections between the two different components, and also what is the external load is going to apply in here. I need to provide that. Here, I am applying around 1350 Newton. So, once if I done this, the software will give me the results. For this load, where is the maximum stress will occur? So where is the damage will occur? The software will give me the maximum area, and also I can able to find out the displacement, how my product will elongate. I can able to animate this to get the better understanding. So, and also one more thing, after this I can also able to find out the factor of safety. So how much amount of factor of safety my product is having. So here it is having around 1.3. So I need to strengthen my model to maintain the factor of safety of 2. So depending upon the company standard, they can find out the factor of safety value here, and they can either improve their design, or if they are using more raw material, they can able to reduce the raw material by doing this kind of analysis. So once if you are unsure about your strength, and after that how long will my product will survive, that is what the scenario. By using this only we can give the warranty, and also we can give the service period for our customers. So it is actually the upfront validation tool for to identify the lifetime of your product. How long will my product will survive if it is keep on in the same loading conditions, and also when I need to give the preventive maintenance for them, and also what is the service life of my entire product. Those kind of things you can able to identify by using the SN curve. So here actually once if you've done the static analysis, you can able to identify the lifetime of your product. So where my product is having the maximum damage after once it reaches the lifetime, and also you can able to see how long it will survive. So around in this crank will survive for around 3 million cycles. So after 3 million cycles, it will getting into the damage in this area. So after that, I need to provide a service for this crankshaft to maintain this strength without affecting the working conditions. So by this I can able to ensure my product will survive for the long last before the maintenance period, and when I need to provide the service preventive maintenance for the customers, and also how much amount of time I can able to give the customers for a warranty. Those kind of things I can able to identify. By using this, you can able to reduce your product life cycle, and also you can able to improve your product quality. So with this, you can able to get a benefit of reducing your design cycle time, obviously, and also you can able to get reach the market with a proper clarity, and also you can able to reduce the distraction between the design team and also as well as the manufacturing team. You can give the clear cut manufacturing drawings, manufacturing animations, exploded views to your customers and also with your shop floor pupils. So with this, I'll end up my session. You can able to get around 60% of reduction in design errors. You can able to give the customer in a different varieties of machines instantly, and also the 3D content central. It is actually the cloud library. If you doesn't have any standard components inside the toolbox, you can able to search it by the way of supplier wise and also the product wise. You can get it and use it in your design. The automated BOM will be really helpful for your purchase to get the exact requirement to do the entire assembly, and also you can eliminate the structural failure, and also by making investing lot of money for to making the prototype, you can able to do all those kind of predefined checkups, upfront validations during the design stage. So if you are making any modification in your design, that also will reflect in your assembly level as also in your documentation drawing level. So these are all some of our customers, EGS customers in and around Coimbatore. So thank you for your patience. Once again, thank you.